Newton's law of cooling is the equation T of T equals T sub m plus T sub 0 minus T sub m times e to the negative kT power, where T sub m is the temperature of the surrounding medium, so basically the air temperature of whatever room you're in or whatever box you're in, and T sub 0 is the initial temperature of that object. Okay? So we're going to use Newton's law of cooling to solve this problem. A cake is removed from an oven at 350 degrees Fahrenheit and cools to 120 degrees Fahrenheit after 20 minutes in a room at 65 degrees Fahrenheit. How long will the cake take to cool to 90 degrees Fahrenheit? Okay? Well, utilizing Newton's law of cooling, okay, so we know the fact that it has cooled to 120 degrees after 20 minutes. So we know T of T. We know T sub m, the temperature of the surrounding medium, that's 65 degrees. We know our initial temperature, T sub 0, was 350 degrees. We know E. We know T, in this case it's 20 minutes, but we don't know that K. And we're going to need that K value for our cake to find out what our cake is. So we need to first utilize it to find K. Okay? So let's go with, okay, so the cake is removed and it ends up at 120 degrees. That's going to equal our ambient temperature is 65 degrees plus 350 degrees minus our ambient temperature of 65 degrees. All of that times e to the negative k times 20 minutes. And we need to solve this for k. Well, we can make that be a little nicer. So we can say here that, let's use green, 120 is equal to 65 plus 350 minus 65 is 285 e to the negative 20k power. Then I can subtract 65 from both sides. 55 is going to equal 285 e to the negative 20k. Let's go with minus 65 here, minus 65 there, just so I see what we're typing or what the math that I'm doing. Then I would divide both sides by 285. That's going to give me 11/57. If you wanted to leave that as 55 over 285, totally fine with that because we're not done with the problem, so we don't have to reduce it quite yet. E to the negative 20k there. Then what we're going to have to do now is we are going to have to natural log both sides or switch it to log form on both sides. So we're going to have the natural log of 11/57 equals negative 20k. I would have log base E, which is natural log of my argument, 11/57, equals my exponent, negative 20k. Then I would divide both sides here by negative 20. And I would get a k value here of 0.082258. Now, if you're using a graphing calculator, I would store that then as k on your graphing calculator. If you're not using a graphing calculator, I would write down as many decimal places as you can, just because we're not done with this problem yet. We need to utilize that k now, and so if I just use 0.08, my numbers are going to be way off. Okay? We want to be as exact as possible, so we're going to utilize them as best we can, or as many digits as we can. Okay? So now let's get and answer the question, how long will it take cake to cool to 90 degrees? So now my equation is going to be 90 is equal to 65 plus 350 minus 65 times e to the, let me move this over a little bit so I got room to write my e in here, times e to the negative 0.082258 t power. And now what we're doing is we are going to solve for that t. So the math is going to basically be the same, but the numbers will change a little bit here. So this is 90 now equals 65 plus 285 e to the negative 0.082258 t power. Subtracting 65 25 is equal to 285 e to the negative 0.2258 t power. Dividing by 285. Gives me 5/57 if I reduce that fraction. Again, if you want to have it be 25 over 285, totally fine with that. 0.8228 t power. So again, we would natural log it here. Okay? And so then we would switch over to the natural log of 5/57, then would equal negative 0.082258 t. And then again here now we would divide both sides by that negative 0.082258 value. And that would give us a t value of, bring this up a little bit, right, so low, 29.5852. So this answer here, our cake would cool to 90 degrees in approximately 29.59 minutes.